Welcome to another video. In this video, we're going to talk about documentation that won't lie, tests that catch bugs, and best practices for producing clean code. We'll start with documentation. The guide by Matt Gentzkow and Shapiro suggests two different rules for documentation. First is to don't write documentation that you won't maintain. And second is to make code self-documenting, which is an offshoot of their rule to automate everything. If we can automate documentation, that will make sure that the documentation functions better for us. Let's illustrate the power of documentation with some code that I've got ready to share. At the top of this file, we've got a bad example where the comment above this line of code, it's calling the estimate OLS function that we talked about in a previous video. And the comment on the code says this calculates a regression with 500 observations, but nowhere in here does it mention what the sample size is. A better approach is, instead of having y and x, you can call it outcome variable and design matrix or covariate matrix. And this is an example of self-documenting code. The reason why is that the variable names and the function names are not going to get out of sync in the same way that a stray comment would. And that's because the variable names and the function names have to run when we run the code, but the comments don't. Another example with documentation and making it self-documenting is Julia's docstrings functionality, which also exists in Python. Here's an example of how docstrings work in Julia. We use triple quotation marks. This is the same syntax as in Python. And before we define the function, we give a little bit of background about what the arguments are and what the function does and what it returns. And when we put these in, this will allow us to make use of the native help functionality that's in the software. And it can also be used to deploy automated documentation packages and so forth. Next, let's talk about unit testing. Unit testing is to programmers what hand washing is to surgeons. Surgeons wouldn't start operating on a patient without washing their hands. That would risk infection. Professional software developers would not start writing code without doing unit testing because that would have deleterious consequences as well. So what is unit testing? Well, unit testing is basically writing a separate set of code that evaluates the function that we're interested in using under different points to make sure that what it's outputting is expected. And the key idea with unit testing is it needs to be high coverage, meaning that we need to test as many different possible cases as possible. And we also need to test as many functions across our code base as possible. And the workflow with test-driven development, or TDD, is first to write a test that fails. And why would we want to start there? Well, we want to make sure that we're writing a test that's going to be informative. If we wrote a test that passed, then it wouldn't really be testing anything. And we also want to make sure that our function is not going to pass our test for the wrong reason. That would introduce an insidious code bug. Once we've written a test that fails, then we're going to update the code in our function to make it pass. And then once it passes, then we're going to optimize our code. We're going to do something called refactoring, which means changing the code without changing what it outputs. And we just go in this loop of test, update the code, refactor the code, and write another test. And we do that until we've got full coverage of our code base. And why does this work, or why is this a good idea? It's because it catches bugs at the source and it forces us to think about what's going into those functions as we're programming them up. And that's a great way to catch bugs, in the same way that hand washing is a great way to catch germs before introducing them into somebody else's body. In the last part of this video, I just want to talk about some best practices and work habits. So first, if we want to produce clean code, it's best to do so in a distraction-free environment. That means blocking off long periods of time, at least an hour and a half, up to 3 or 4 hours, to focus on writing the code, and not having any distractions, no email, no Slack, because those distractions can get us out of the mindset and not be successful and actually introduce bugs into our code inadvertently. The reason that we need to be distraction-free is because a lot of programming requires holding information in your your temporary memory. And if you're switching to different contexts, you can lose some of that temporary memory, and then it will either take you longer to produce the same amount of code, or you'll produce worse quality code. If you want tips about how to work in a focused and undistracted manner, I would recommend Cal Newport. He's the author of the book Deep Work, and also has a podcast called Deep Questions that he releases weekly. Another aspect of producing clean code is called pair programming. This might seem counterintuitive, but it's often the case that better code is produced faster if two people are sitting at the same computer. And there's a few reasons for that. We call this pair programming because there's a pair of people doing the programming. And basically we have one person who's touching the keyboard, they're the driver or the pilot, and then someone sitting next to the driver or pilot called the navigator or the co-pilot, and they're giving instructions, making sure that typos aren't introduced, and keeping a bigger picture eye on things while the driver actually inputs the code. Nowadays with AI tools, there's, for example, GitHub Copilot, and the reason it's called Copilot is from this pair programming model, aims to be your AI pair programmer. One aspect of pair programming that I think doesn't get talked about as much is that having a physical person sitting next to you can be really helpful for keeping you both on task and focused and not wandering to a Slack message or a text message or an email, and also treating it like it's an actual meeting as opposed to just time at work. Finally, how do we manage tasks in a clean coding environment? I talked about it a little bit in the previous video where we introduced GitHub, and we talked about the GitHub issue tracker. GitHub issue tracker is a great tool for managing tasks separately from email so that you don't get distracted. Because I can open up, if I'm in my focus session, I can still open up my GitHub issues and look at them, and I know I'm not going to be bombarded about what restaurant are we going to dinner tonight, or can I pick up the kids from school, these types of things that are irrelevant to the task at hand. Alongside GitHub issue tracking, you can also use tools like Trello or Kanban that will keep everyone in sync about who's doing what task and what their timeline is for finishing that task. The name of the game is to not do task management through email or through Slack or other sorts of what Cal Newport calls ad hoc back and forth messaging systems. And the reason for that is because that's going to introduce a lot of stray information that's not pertinent to the task, and it's going to cause more cognitive overhead to keep that information in your head as well as the information about the code that you're writing. That's it for this set of videos on clean coding. I hope that you found something worthwhile, and I hope to see you again in another video.